This is Module 11, Lesson 1, and what we're going to talk about today is called stoichiometry. What it does is kind of puts together what we learned in Modules 9 and 10. That's combining what we've learned about moles and how to do mole conversions with chemical reactions. So to give you an example of what this would basically be like, I'm just going to make up, some sort of problem here. I usually like to use sandwiches as an example. Peanut butter and jelly sandwiches would be a good place to start. If we were going to write a recipe for a peanut butter and jelly sandwich, we write something like 2 slices of bread plus 2 tablespoons of peanut butter. And then let's just pretend like we really love jelly, so we're going with 3 tablespoons of jelly. And what it does is that makes 1 sandwich. Well, stoichiometry, what it does is kind of takes this is kind of our chemical equation, it's our recipe. And what stoichiometry does is it helps us compare the amounts of things in an equation to itself. So for example, we know that there's a ratio here. We know that it's 2 tablespoons of peanut butter to 3 tablespoons of jelly. And we know that there's 3 tablespoons of jelly to 1 sandwich. Or you could say there's 2 tablespoons of peanut butter to 1 sandwich. So, we can make comparisons about the amounts of things that are in this equation or this recipe because we have the recipe for it. So, for example, if we were going to take, say, a question of, well, how many sandwiches could we make with 41 slices of bread equal blank sandwiches? Well, we could work that problem out. Whoops, I didn't mean to skip ahead. We could totally work this problem out. What we would have to do is we could do a conversion problem with it. We could do like 41, I'm just going to put bread because writing all that's kind of difficult. We could do 41 slices of bread. And then we know that it's a ratio of 2 pieces of bread for every 1 sandwich. And we would get us an answer. Now, of course, like this will not make a complete sandwich. This would make 20 and a half sandwiches. And it always seems pretty common sense at this point when we're doing the sandwich equation, like, yeah, well, that all makes sense. Well, we can do the same exact thing if we're using a chemical reaction. So what we're going to do is we are going to calculate the amounts of things in chemical equations like I just did with the sandwich equation. And so here are the steps to our problem solving right here. What it says to do first is make sure the equation is balanced. Convert the given quantity to moles if you're not already in moles. So it's very important that if we're doing these that you get to moles. Use a mole ratio to switch substances. Well, what's a mole ratio? You might ask. Well, see right here. Here's a mole ratio. A mole ratio is simply moles of one substance to moles of another substance. And then it says convert the moles to the desired quantity. So I think the best way to show you what this looks like is to do several problems. So I would recommend that you do these on your paper, and if necessary, watch them a couple of times in order to get the hang of it. So right here, here's our balanced equation. It's already got the coefficients for us. I don't need to balance it. If you want to check, you can, but it's balanced because I've already seen that part of it. So what I told you to do next is convert to moles, if necessary. So the question is, how many moles of aluminum, or here's the question, how many moles of aluminum, the question, are needed to form this many moles of Al2O3? So this is just like what we did in our previous problems. We're going to start with what we're given. So we're going to start with this right here. We're going to start with the 3.7 moles of Al2O3. Now, if you were not writing the substances like the Al2O3 in your problems back in Module 9, you're going to want to now because they are going to cancel out. I don't know if you can tell by looking at this or not, but we're actually going to switch substances. It gives me information about aluminum oxide, and then it asks me about aluminum. That's what's different from our problems before. When we did this before, we did not need an equation, and we went from something about one substance to something else about that same exact substance. This time we're switching substances. Well, how we switch substances is we know we have to put mole down here and the same substance, so they cancel out. Mole is where we switch substances. I didn't mean to make that box pop up. So what we're going to do on top, moles of the next thing. What is it asking me about aluminum? And I'm going to put moles of aluminum on top. Well, how do I know how many moles of aluminum to how many moles of Al2O3? Look right up here. We're going to use the coefficients. It's just like my peanut butter sandwich example. Instead of it being like 4 slices of bread, it's 4 moles of aluminum. We can interpret this equation as 4, we could even write it this way, 4 moles of aluminum plus 3 moles of O2 produce 2 moles of, and we could even write it oxide or just Al2O3. We can look at these coefficients as moles. So what that means is it's 4 moles of aluminum for every 3 moles of oxygen. And it's 4 moles of aluminum for every 2 moles of Al2O3. Well, that's the ones that I need in this problem. So I'm going to put the 4 that goes with aluminum right here because it's aluminum. And I'm going to put the 2 that goes with Al2O3 right here. It's 4 moles of aluminum to 2 moles of Al2O3. Now at this point, moles of aluminum oxide cancel, and if I do my math right now, I'm left with moles of aluminum. Well, y'all, that's exactly what it's asking me for right here. It's asking me to find the number of moles of aluminum. So what that tells me is I don't need to go any further. I just simply need to do math at this point. So if you do your math, you'll find that this equals 7.4. So we need, of course, to look at the sig figs. Well, remember, everything that's past this given information doesn't count in terms of my sig figs because it's all got an infinite number of sig figs. It's all understood quantities. So I just simply look back at what I was given. I was given 3.7 that has 2 sig figs. This has 2 sig figs. So put the units on the end of it. So my answer is 7.4 moles of aluminum. Now, I do know that there are some of you, due to various reasons, who did not do a lot of Module 9 at the end of the 9 weeks, which means you're probably pretty confused at this point if you didn't do Module 9, because we're using all of that to do this. So if that's the case and you don't understand any of the small stuff, or you're forgetting the process, then you need to go back to Module 9. All right, here's your next problem. The next one says, how many moles of oxygen are required to, well, that should just be react. I haven't misspelling there. Are required to react completely with 14.8 moles of aluminum. So same exact equation, just a different question this time. So here's my question. How many moles of oxygen are required to react with this? This is my given information. So I'm going to write my given info down because if all else fails, we can memorize kind of a procedure. Moles of aluminum goes first. Okay, moles of aluminum has to come down here because I need it to cancel out. Now, what am I trying to get to? Moles of oxygen. So I put moles of oxygen on top. Now, how do I figure out how many moles of each of these things comes from the coefficients? I just need to find the right ones. O2 is up here, so find O2. Right here it is. It's got a 3 in front of it, so that's 3 moles of O2. The other one is aluminum. Well, that's right here. There's a 4 in front of that. So it's 3 moles of oxygen to 4 moles of aluminum. Moles of aluminum cancels. Do I need to go further? Do I need a bar and another step? Look right here, it's what it's asking. How many moles of oxygen? Well, this is moles of oxygen. So I don't need to go any further. I just simply need to put my equal sign. And I'm doing the math of these as we go just to make sure that it actually comes out to what I put on the paper. And so yes, the calculator says 11.1. Well, can I keep those sig figs? We're not going to look at my answer here. We're going to look at the problem like you should be doing. This has 3 sig figs. This doesn't matter. So 3 sig figs it is. That's 3. So we're going to finish it out by putting the units, moles of O2. So there's my answer. Now, the first 2 problems that I've done have been pretty straightforward because we start with moles and we end up at moles. So what if it's kind of a bigger problem. And so for now, let's see if it's a bigger problem. If we have Al2O3, well, we've got the same thing, like same kind of question. How many moles are formed when 0.78 moles of oxygen react with aluminum? So here's the deal. I know it mentions aluminum, but that's kind of like me saying, how many peanut butter and jelly sandwiches can I make out of 300 tablespoons of peanut butter if I put it together with jelly? Like, the jelly part doesn't matter. We're assuming that we have enough of this stuff. Like, I don't even care about this part of the sentence. You can just pretend like it goes completely away and focus on this. How many moles of Al2O3 are formed when 0.78 moles of O2, react? That'd be good enough. Again, we start with what we have. So we've got 0.78 mole O2. Okay. Moles of O2 has to come down to the bottom. Okay. Can I go to moles on top? I can, because we can put moles of one thing over moles of something else. So how many moles of Al2 is up here? That would be 2. How many moles of oxygen? That's right here. That would be 3. Okay, I don't need to go any further because it asked me for moles and it gave me moles. So I get to stop right here, and I'll just double check my math. Yes, I agree. I get 0.52 with sig figs. This is 2 sig figs. This is 2 sig figs. So I don't need to change anything. I just need to finish it out by putting my units on there. Okay. Now, my next one's another mole to mole. I'll change it because we need some different types of problems. Okay, this one is not moles to moles. This one is something that is far more complicated. So this one has how many grams of aluminum. This is different. We're dealing with the same equation, and it would be used to produce this many grams of Al2O3. So notice what's different from before is I don't have moles to moles. This time I have grams to grams. You cannot interpret this equation as 4 grams of aluminum plus 3 grams of O2 makes 2 grams of Al2O3. One thing that you should have learned back in Module 9 is that a mole of a substance has its own number of grams. Remember, we learned how to calculate that, the molar mass of a substance. The number of grams of each of these things is unique and individual to itself. And so this is where we're going to really combine Module 9 in with this. What we're going to have to do is we're going to have to get from grams to moles, and then from moles back to grams. Now, that may sound like we're just going to undo our own work, but no, we're not. So watch what I'm going to do. I'm going to start once again with what I'm given. I'm given 200 grams of Al2O3. Okay, so we know by now that whatever's up here has to go into the bottom of the fraction that's next to it, so it'll cancel out. Okay, I told you you have to get to moles. Well, it just so happened in our first 3 examples that we were already at moles. So we need to get there this time. Now, I cannot go from grams of Al2O3 to moles of anything else. I have to go to moles of the same substance. This is an old problem. This is one that we did in Module 9. You should know how to do this. So we learned how to calculate the mass of 1 mole of something. So the mass of, oops, I touched the button that might have popped up the window. The mass of 1 mole of Al2O3. Let's see, aluminum have a mass of 27, so there's 2 of those. The mass of this should be 102.0 grams. Remember, we used the periodic table to calculate the molar mass. So I added up 2 aluminums and 3 oxygens. Okay, that cancels. And if I stop right now, I'm left with moles of Al2O3. Well, that's not what it asked for. So I'm not done. I put it in a bar and another part of the table. Okay, well, we know that whatever's up top has to go across and down in the next one. So moles of Al2O3 has to go down here. Well, remember, what what's special about being at mole is that once I get here, I can switch substances at mole. We got to mole in this step, so I couldn't switch substances. Once I have moles on the bottom, I guess basically that's how you can think of it, is once you get moles down here to the bottom, I can switch, okay? How we find this number is the coefficients. There's 4 moles of aluminum to 2 moles of Al2O3. Okay, so that makes those cancel. Can I stop? Well, if I stop right now, my answer will be moles of aluminum. Look right here. It's asking for grams. I cannot stop. So once again, we're going to have to make another bar. Moles of aluminum has to come down here to the bottom so that it'll cancel out. And if I have moles of aluminum, I can calculate grams of aluminum. How I do that is using the reference table. The reference table tells me that it's 26.98, so we're going to round that to 27.0 grams of aluminum, and I know that's in 1 mole. So if this cancels, can I stop now? Well, if I stop, it's in grams of aluminum. Well, look here, that's what it asks for, grams of aluminum. So yes, now I can stop. So what you would do now is you would multiply all the way across. You'd have 200 times 4 times 27. And then you would divide that by 102 times 2. And you will get I'll put it down here, 105.882, and it just keeps going and going in my calculator. Oops. So, well, I'm just hitting all kinds of buttons here. So, can I keep all of that? The answer is a big fat no. Okay. This has 1 sig fig, so my answer can only eat this first digit. Oops. So that'll round to 100 grams of aluminum, which matches up with what I have up top. Now, since I only gave you one example that's harder, what I'm going to do is I'm going to erase what's on the screen and I'm going to make up a different problem. Sometimes as I go through this, I realize, like, hey, I really wish that I had given you a different problem. Let's just erase everything. And we're going to ask a different question. We're going to ask how many liters of oxygen would react with, and I'm going to change the number up, we'll just make it something different, 143 grams of Al2O3. Can we do that? Sure. It's the same idea. We're going to start with what we know. So we're going to start with 143 grams of Al2O3. So the first thing that you should be thinking is when it asks you about one substance and gives you another, I need to get to mole to make the mole ratio. So our first step is to put grams of Al2O3 down here at the bottom. Okay, so then I can put mole of Al2O3 up top. Like, I need to get 2 moles, and the moles, I can do that with moles to grams. 1 mole of Al2O3, I believe I said, had 102.0 grams. We calculated that before. Okay, that cancels. I cannot stop because it's in moles of Al2O3 and it's liters of oxygen. So we keep going. Okay, mole of Al2O3 goes down here on the bottom. Now remember, once we've got moles on the bottom, I can do my mole ratio, and I can switch. Oops, this is not aluminum. I can switch to the substance that I want, and what I want is oxygen. Okay, I need to get to moles of oxygen before I can convert to liters of oxygen. Okay, so that would be 3 moles of O2 for 2 moles of Al2O3. Those cancel. I cannot stop because this is moles of oxygen and it wants liters. Now, if the question said moles of oxygen, if it asked me how many moles of oxygen, we would stop right now because that's definitely a problem that it could ask, or that I could ask, or the final exam could ask. But I'm just trying to make them complicated so we can work some of the biggest ones, assuming if we can work the bigger ones, you can work the smaller ones. Okay, moles of oxygen goes on the bottom, and then I can do liters of oxygen. Now, this is a throwback to Module 9. Remember that as long as you had a gas, it was 22.4 liters of oxygen per mole. This is on your reference table. You do not have to memorize it. So moles of O2 cancels out, and I'm left with liters of oxygen, which is what it's asking me for. So what do? We crunch numbers. 143 times 3 times 22.4. And we're going to divide that by 102 times 2. Don't forget to put parentheses around that. And that gives me 47.1 using sig figs. My calculator says 47.0, no, sorry, 1058, blah, blah, blah. So, and somehow I just ended the slideshow. I'm having all kinds of difficulties here. Well, I'll just get back to it. I don't know what I did, to be honest, and I'm not re-recording all this, so you get to watch my fumblings here. So right here, we have all of this. We have 47.1, and then it would be liters of O2. Okay, so that would be our answer for this particular problem. All right, I want to do one more just to show you, like what could happen with this. So I'll do this one in blue. I'm not going to erase this because I do want to make a point in just a second about some things. So what if I ask you to find the number of O2, let's see, molecules from 16.2 moles, or to go with 16.2 moles of aluminum. Okay, we want to go from 16.2 moles of aluminum to the number of oxygen molecules that we need to go with it. Can we do that? Yeah, it's just like this. We're going to start with a different number here. We've got 16.2 moles of aluminum. Okay. Moles of aluminum has to go on the bottom. Now this one should be slightly easier. Why? Because I started with moles. In other words, I can cut out this first step right here of converting to moles, and we just start from there. So once I put the moles of aluminum on the bottom, that means I can switch substances. I can go to moles of O2. This is our mole ratio. This is our mole ratio. Okay. How many moles of aluminum? It takes 4 moles of aluminum to go with 3 moles of O2. Moles of aluminum cancels, and then I have to put moles of O2 in the bottom. I can't stop because I want the number of oxygen molecules. So how did we do the number of molecules? We also did this with the number of atoms and the number of formula units. Remember, it was that there's 6.02 times 10 to the 23rd of anything in a mole or 1 mole. We're going to go back and we're going to use that number. Okay, that's the only thing that I've not used from Module 9 in these problems for today. So moles of oxygen cancels. And what I'm left with is doing all of my numbers. 16.2 times 3 times 6.02 to the 23rd, and then divide that by 4. And all of my very quick makeup work says that the answer is 7.3143 times 10 to the 24th. Can I keep all of that? Well, absolutely not. We've got this. This has 3 sig figs, which means I get to keep the first 3 digits. So 7.31 times 10 to the 24th, and here's what I put on the end of it. Molecules of O2. Now, a couple of things that I want to point out to you before you go. Hopefully you're still listening and haven't decided that you've gotten all this. This right here in green and this right here in green, these are mole ratios. We're comparing moles of one substance to moles of something else. We did not do that in our previous problems. I also would like to point out one other thing about this. Remember that when you did this before, you had the number 1. Let's see if I can highlight some of this. We had 1, like here, here, and here. We had 1 going with mole, right? So then, why do I have the number like 3 going with mole and 2 going with mole? I guess basically, how do I know when to put the number 1, and how do I know when to pull them up here from my equation? Well, the answer to that comes down simply to this. When you are putting mole to anything else, like in this right here, I have moles compared to grams. Anytime you have moles to anything else, moles to grams, moles to liters, moles to molecules, you always have to put the number 1 with mole. And see, that's true of each of these circumstances. But whenever, let's switch colors here. Whenever moles with moles, moles with moles, I don't have the number 1 up there unless it came from a coefficient up here in the chemical equation. Okay, so moles with anything else, you put the number 1, because you know all of these things for a mole. You know the mass of 1 mole, you know the volume of 1 mole, and you know how many molecules or any kind of particle are in a mole. But when you have mole to mole, when you have a mole ratio, you must pick the numbers from the equation up here and not from anything that's just coming out of your head. Hopefully that will make it a little bit simpler to remember what to put where. Now, this would be another time where I would not be surprised at all if several of you wanted some of these done with you during office hours. So remember that Monday, Wednesdays, and Fridays, right now, like if you're watching this video right now, we have those scheduled, and then Tuesdays and Thursdays, they're scheduled at a different time, maybe a different way and a different day and time. But remember that you can join me for office hours, or you can request an individual conference of your own, and I will be happy to work some of these with you. So it's your turn. You know, like what you need to do is you need to try this. You need to check your answers at the end of it. And if you're not able to get those answers, then you absolutely need to be asking me something. You need to be able to show that work too, okay? So go ahead, practice away.